Hello dear students, in this video I will explain how to do amplifier analysis or AC analysis or small signal analysis of BJT directly without drawing any model, that is RE model or T model, pi model, H model. You need not require to draw any model, directly you can do the analysis. Okay, but before that you have to watch my previous class. In that I have explained certain concept like this. Okay, and the video title is BJT concept like never before. You can go to the playlist and you can find this lecture. Okay, so first watch that lecture and then watch this lecture. Okay, so amplifier analysis or AC analysis, in that all the capacitor, while doing amplifier analysis, all the capacitors act as a short circuit, or under small signal condition all the capacitor act as a short circuit. All the DC sources are connected to ground. All the DC sources are connected to ground because we are doing AC analysis. So like superposition theorem, all the DC sources are 0. So here all the DC voltage sources are connected to ground. So first of all, make all the DC sources are connected to ground. All the capacitor act as a short circuit. So this CB short circuited, this CC short circuited, this is also short circuited. So this external capacitors offers very low resistance, ideally speaking 0 ohm, that is short circuit. Okay, now next need not require to draw any model, need not require to replace BJT with RE model or H model or pi model, directly you can do. So in previous class already I explained that there is a resistor between base and emitter, dynamic resistor between base and emitter, which is small re, through which emitter current is flowing. Okay, now see, this is connected to ground, so this capital RE will bypass according to the network theory concept. So this is 0 volt. So here also at this node this is 0 volt. Okay, this is base current, already I explained in previous class. Now you can see guys, this R1 and R2 will come into parallel according to the network theory. So we can write here R1, I am writing here equivalent resistor, that is R1 parallel R2. So you can remove R1 from here, just remove R1 from here. Similarly at output side you can see guys, at this node you can see this RL and RC will come into parallel according to the network theory concept. This RC and this load resistor will come into parallel. So here we can write RL parallel RC. So just remove RC from here. Okay, now next guys, we want to find in amplifier analysis or AC analysis or in small signal analysis, we want to find its voltage gain, that is V out upon V in, then input impedance seen from the input side or seen from the base side, and output impedance seen from the load side. Okay, first we will find the voltage gain. So it's very much easy guys, and here this is the dependent current source, which is nothing but GM into VBE, where VB is potential drop between these two terminal, that is VBE. Here this voltage is nothing but base voltage VB, and we can mark this is VE. So VB equal to, see, this is V in guys, this is V in. So here I am writing VB is equal to V in. Similarly, what is emitter voltage? So emitter is connected to ground, so emitter voltage is 0. So we can write here VBE is equal to V in. Okay, now come to the output side. So this current is GMVB flowing like this, so flowing from ground to output node. So that's why directly using network theory concept we can write it is nothing but current, Ohm's law, minus GM into VBE into RC parallel RL. Now we want to find VB, and already we have VB. VB is nothing but V in. So here this V in is equal to VBE. So voltage gain, which is nothing but the ratio of output voltage upon input voltage. So VB cancel out, it is nothing but minus GM into RC parallel RL. Like this you can solve guys. Now suppose if you want to solve this question in another way, like beta into IB, that also we can do guys, that also we can do. So just see here, just see here. Now see, this is what beta IB current. Okay, this is nothing but beta into IB current. Okay, so we are not focusing on VBE, Okay, now see here, all of you, see here again this voltage is V in, this voltage is nothing but V in, and this is 0 volt. This ammeter voltage is 0 volt. So this is nothing but potential drop across R is nothing but we can mark V in. So in this case, now V in is equal to small Re, Ohm's law, and current is IE. Now ammeter current is, we can replace ammeter current with beta plus 1 into IB, and this is also known as R pi. Yes, we know that this is also known as R pi. Okay, now output side again same thing, but there is a change in current, guys. Change in current. Now we are considering collector current is beta times IB into RC parallel RL, and input we got small Re into beta plus 1 into IB, and if you take the ratio, then you can get the voltage gain V out upon V in. V out upon V in directly, IB cancel out, that is minus beta upon small Re into beta plus 1 into RC parallel RL, and this is nothing but GM, guys. This is the formula for the GM. Okay, you can replace this with GM. So in this way also you can get the same answer. Okay, now here we found voltage gain. Now we can find input impedance and output impedance also, guys. So see how to find input impedance. Like input impedance seen from the input side, like from here, source side. So here we want to find Rin, correct? Now already in last class, in previous class, I told you, see here, I told you if this ammeter terminal, if ammeter terminal is connected to ground, you can watch the previous class. If ammeter terminal is connected to ground, then the resistance seen from the base side, between base and ground, this is the resistance seen from the base side, that means between base and ground, the resistance seen from the base side, between base and ground, we can say between base and ground is nothing but small Re into beta plus 1. Already I told you in the previous class, you can watch the previous class, which is nothing but R pi. This is between base and ground. Then what is the resistance seen from here? So of course this R1 parallel R2 and this resistor, so here we can mark R1 parallel R2 parallel R pi, and similarly same thing here, from here we can say input resistance R1 parallel R2 parallel R pi. So you can see, guys, need not require to draw any model. With the help of this concept you can solve easily, correct? Okay, now similarly we want to find output resistance seen from the load. So while calculating output resistance, first of all you have to remove load resistance. So in output resistance or output impedance, load resistance will not come into picture. We are not considering the load resistance. So this is the input resistance seen from the input side. Now we want to find output impedance seen from the load side. So you have to remove load. So if you remove load, then this is only RC, RL infinite, only RC, and we want to find resistance, output impedance or resistance seen from the load side. Okay, so let me remove all this thing. So now you can see, guys, it is like RThevenin. Finding RThevenin, output resistance is nothing but same as finding RThevenin. Okay, so amplifier is a dependent amplifier and this is independent voltage source. So this circuit consists dependent source as well as independent source, like this is the dependent current source and this is the independent voltage source. So in this case, according to the network theory, while finding output resistance or RThevenin, first of all the independent voltage sources are connected to ground, that is 0 volt. So this input is 0 volt, guys. So here at base terminal 0 volt will come into picture. So here at base 0 volt, ammeters are 0 volt. So you can say this ammeter current here 0. Now once ammeter current is 0, then we can say base current also 0. So if base current 0, then what about its dependent current source? If base current is 0, then this act as open circuit because this dependent current source also 0. So it act as open circuit. Now see, output is completely disconnected from this circuit. So we can say what is the resistance seen from the output side? Simply you can mark RC. Okay, so guys, you can see here, you can see with the basic concept, basic understanding of BJT, you can directly get the answer. Here we can save time by not drawing the equivalent model of BJT. Okay, so remember this approach, guys.